Good morning again. Happy Thursday, everyone. Thanks for joining us. I'm Megan Hoy, the Engagement Manager at the Center for Energy and Environment, and we're really glad to have you with us today. Um, uh, Before going much further, I would just like to introduce Mary Sue Lobenstein, who is the Conservation Improvement Research and Development Program Administrator at the Department of Commerce, Division of Energy Resources, to kick us off with our introduction for today's webinar.
Good morning. Welcome to this Conservation Applied Research and Development, or CARD, webinar. As Megan said, I'm the R&D Program Administrator at the Minnesota Department of Commerce Division of Energy Resources. And this webinar is one in an ongoing series designed to summarize the results from research projects funded by Minnesota's Applied Research and Development Fund. The Applied Research and Development Fund, could you go to the next slide? Yeah, thanks. Was established in the Next Generation Energy Act of 2007. Its purpose is to help Minnesota utilities achieve their 1.5% savings goal by identifying new technologies or strategies to maximize energy savings, improving the effectiveness of energy conservation programs, and documenting CO2 reductions from energy conservation programs. $2.5 million of this fund is set aside annually for the CARD program, which awards research grants in a competitive request for proposal or RFP process. Since the legislation was enacted, the CARD program has had 8 funding cycles with 21 posted RFPs, received nearly 380 proposals, and funded 92 research projects, representing over $21 million in research dollars. As you can see by the pie chart, projects funded to date have been in all building sectors. The subject of today's webinar is in the commercial sector and summarizes the results of a project which investigated ways to optimize the performance of condensing boilers. It'll be presented by the Center for Energy and Environment.
Thank you, Mary Sue. Thanks for that introduction from the Department of Commerce. We're very excited to be able to present to you today's webinar, and just to get us started, as a nonprofit whose mission is to increase energy efficiency while strengthening the economy and improving the environment, the Center for Energy and Environment is on the ground working to discover and deploy the most cost-effective solutions for healthy, low-carbon economy. And we're involved in a variety of ways in the community and in our region, as you can see on the slide here. So at the with the topic at hand, condensing boilers, for all of us who are excited to do some technical learning or geeking out, as we might like to refer to it, today's topic is on condensing boilers. Condensing boilers are one of the most promising natural gas technologies for reducing commercial energy use in Minnesota. However, many newly installed systems only achieve a fraction of their expected energy savings. Boiler equipment and controls are often based on standard operating conditions, which are different than the conditions needed to perform ideally, and modifications may be needed to achieve optimal performance. The Center for Energy and Environment recently completed a field study on the impact of actual operating conditions on condensing boiler efficiency in Minnesota commercial buildings. The research identified opportunities for significant savings from the temperature control settings and optimization and other low-cost upgrades. Today, to tell us about the findings and recommendations, we have with us, we're very lucky to have with us, Russ Landry, who's a senior mechanical engineer here at CEE. I have the pleasure of working with Russ very closely, and I would like to just add that he's very has a lot of deep specialization in commercial building systems. But Russ began working here at the Center for Energy and Environment as an engineering intern in 1990. Over the course of his career, he has performed in-depth analysis and monitoring of building HVAC systems to evaluate the use of energy savings technologies in existing buildings. Russ has also worked extensively on analyzing opportunities for utility energy savings through market studies, technology evaluation, program design, utility staff training, field evaluations, building assessments, design and retrofit technical assistance. Since 2005, RUS has been increasingly involved in new construction to provide plan review, whole building energy simulation, and other technical support to design teams and organizations involved in oversight and verification. RUS's most recent work includes review and documentation of new construction projects against Minnesota's Sustainable Buildings 2030 Energy Standard, the Enterprise Green Communities criteria, the Energy Star Multifamily High-Rise Program, and the 2015 Minnesota Energy Code, as well as field research into optimization of indoor pool facilities and what we will hear about today, optimization of condensing boilers in commercial buildings. So without further ado, I would like to hand it over to the expert himself.
I appreciate all of the interest that you have in our research and the chance to share that with you. Today, what was it? Okay, no title at all. Okay. I'm going to start by talking about just a little bit of background on condensing boilers and how they outperform conventional boilers and achieve the higher efficiency ratings. With conventional boilers, all of the water vapor that's generated when natural gas burns and combines with oxygen in the air to get the heat out of it. At the same time, a major byproduct of that is water vapor besides the carbon dioxide. And with conventional boilers, all that water vapor, which you could consider steam, goes out the vent. You can see that on a cold day when you look at a chimney and you see the cloud of vapors condensing. That's what you could consider steam going out the vent. And besides just the loss of the energy from the water vapor, conventional boilers are designed. They don't have safety factors to make sure that they don't ever condense. If you look at a conventional boiler, they really want to not ever have the condensation happening. So they're designed to make sure that doesn't ever happen, and then that provides additional inefficiencies. Now this is going to kind of show an animation of what that looks like. A couple of them here to kind of show the difference. Here's with the conventional boiler. Oh, I guess we're starting out with the condensing boiler here. It's showing how with the condensing boiler there's not a lot of steam coming out of the vent here, as opposed to the conventional boiler. There's quite a bit more steam coming out as some of that water vapor is condensed, and that the heat from the condensation of that water vapor is captured and then used within the heating system. So condensing boilers, again, have the benefit of capturing some heat from that steam or hot water vapor, and they don't have the safety factors that cause inefficiencies in conventional boilers. And even though that steam that water vapor is not a high volume of it, it carries a great deal of energy with it, and then the 1 pound of steam or water vapor that's condensed can heat 50 pounds of water by 20 degrees, and that's in a typical boiler design. They would be heating water by 20 degrees, so you get a lot of bang for your buck in capturing that condensation. And then looking at the benefits of condensing boilers over conventional boilers. A conventional boiler, typically you're not going to get over 81, 82% in terms of operating efficiencies, and more typically you're going to be more in the 80% range. So the orange here is kind of showing at the top conventional boiler efficiency, and then the next two bars kind of show the range of what could be achieved with a condensing boiler if and what you actually achieve is based a lot on what the operating conditions are within the building. If you have poor operating conditions for a condensing boiler, you're going to get the minimum savings. You're going to achieve an efficiency of around 86, 87%, kind of under any conditions. And under ideal conditions, you'll get something more like what the rated efficiency of the condensing boiler is, and that's going to vary from model to model, but it could be up to 96% efficiency or even a little bit more. So you definitely, in any situation, you're getting some savings, but depending on the conditions that the boiler is operating at, you can get a lot more savings than the minimum. And in terms of what's happening in a actual building, it's kind of a question mark in a lot of cases in terms of what's actually achieved. And I know that there's a lot of utility programs that are promoting these the condensing boilers, and there's been a lot installed. And there's variations in terms of what people are seeing for their actual performance and savings. And the most important factor in terms of getting the best performance and our energy value out of a condensing boiler, just like in real estate, there's 3 rules in terms of the value is location, location, location. When it comes to performance of condensing boilers, the 3 most important rules are getting a low water temperature coming back to the boiler. So that's a low return water temperature, a low return water temperature, and a low return water temperature. And it just makes a huge difference. And it's not necessarily the temperature going out of the boiler out to the building, it's what comes back into the boiler that makes a big difference, so that there's water that's cool enough to condense the water vapor out of the combustion gases. Kind of like you think about on a hot, humid day, you have a cold can of pop, will get the condensation on it. So it's kind of, you have to get it down to a certain temperature to really get that condensation happening. And this shows, this kind of shows that this is an example plot of efficiency ratings for a model of a commercial condensing boiler. And you can see for this particular one, they're talking about achieving a 90% efficiency rating under conditions where it can't condense over on the right. And then as the return water temperature goes down further and further, you get the efficiency going up dramatically. And one thing I also want to point out here is that oftentimes it's kind of oversimplified in terms of condensing boiler performance, that people will talk about, are you getting it to condense or not? And that's kind of at the 130 to 120 range. You can see kind of that's just on the far right hand side of when it's starting to really ramp up. So it's not just whether it's condensing or not, it's how much is it condensing makes a big difference. As it starts to condense, you get a little bit of an efficiency gain, but there's still a long range to go a lot farther that makes a very big difference in the efficiency. So it's not just a yes or no, is it condensing? It's a lot more complex than that, and has a lot more energy implications in terms of how far you go. And this kind of shows what might happen in a system that's designed to have low water temperatures. This is kind of showing the typical weather variations on the bottom over the course of a year. And if you have a condensing boiler operating, it's kind of showing on the top what the return water temperatures might be over the year. And then if you have a system that automatically responds with an outdoor reset control to lower the water temperature when the load is lower in warmer weather, then you can have operation below the condensation threshold. But you can see during the colder, for this example, during the colder winter weather, you're not getting as much of the efficiency benefit. You're operating more at that minimum efficiency gain, and it's only in the milder weather that they're getting the higher benefits. And this next slide is showing how in the design of a system, besides the impact of the building and the system controls on the return water temperature coming back, just in terms of the main temperature of the boiler system, also how you can get efficiency benefits by changing the water flow rate in the system. And this is generally done using a variable speed drive on the building loop pumps, not just on the boiler itself. In the larger buildings, it tends to be there might be separate pumps for the boiler and separate for the building loop. But if you slow down the flow out to the building and you have the right design, if you're running at a typical flow at design levels, you might have this kind of return water temperature of 125 in this example. But if you, with that same system, slow down the flow and actually increase the temperature of the water going out of the boiler, if you look at kind of the right-hand part of that bar where it says low flow, it's actually a warmer temperature coming out of the boiler. But if you have it at a low flow, you can have a lower temperature coming back and still get the same amount of heat out of the radiators or air handlers or whatever the heat delivery device is within the building. So you actually get an increase in energy performance by lowering the flow, besides reduction in the pump energy use. And then I'm going to talk about another operating condition factor that can have a big impact, that can have an impact on the efficiency of the boiler, not as much as the temperature, and that's the excess air, or what's addressed by a traditional tune-up of a boiler, and that's just adjusting the mixture of natural gas and air and getting those in the right proportions to operate most efficiently without having carbon monoxide production. And this is showing in one measurement in terms a measurement of how much how well the tuning is the amount of excess air. In this example, this is having 20% excess air, which is fairly low value and pretty well fine-tuned boiler. And if the boiler isn't tuned quite as well and you have 30% excess air, you can see that the efficiency level drops. Drops in this case, even at the same return water temperatures, you end up with a lower efficiency level at the higher excess air, and then that goes it's even more dramatic if you have higher excess air. So you see a significant change with the tuning, and this makes condensing boilers even more more sensitive to having correct tuning than what you'd have with conventional boilers, because besides the extra just temperature difference and extra air heat, when you have excess air, you have extra air that's getting heated up and it's going out the chimney without doing any good. So besides that factor of the extra heat out the chimney, you're reducing its ability to condense, because what happens is the water vapor gets is at a much lower concentration and kind of gets the water vapor or steam in the combustion chamber gets diluted by the extra air, and then the dew point goes down. It makes it harder to condense that water out of the vapors. Now that kind of given a brief background on some of the key operating conditions that affect condensing boilers, going to talk about what we specifically did for this project to try to evaluate the impact and the potential for STIP programs to try to increase the impact of what's happening with condensing boilers in Minnesota. We started out by doing a preliminary market study of talking with local industry contacts to find out kind of what are the different variations that people are seeing in condensing boiler installations, what kind of buildings are they going in, and then based on that information, we picked sites for doing detailed monitoring. So then in the monitoring analysis, we picked a dozen sites representative of 4 different commercial building types, education, multifamily buildings, and then government or office type buildings. That those seem to be where condensing boilers were a little bit more prevalent, and we wanted to get a range of conditions and systems. We also looked at a range of boiler system sizes and some of the other characteristics that vary from building to building. And then we also did an industry survey towards the end of the project to get feedback on potential program improvements that could be suggested based on our findings, and kind of how what the impression is of local industry, and also just to get a little bit better feedback for what people are seeing as problems in the industry, and how things can be made better in terms of the condensing boiler performance. And then last of all, we have done dissemination. First of all, talking about the initial market study, what we're finding is that there seems to be market dominance of condensing boilers, and that they've tended to become in commercial buildings kind of the default choice if someone needs to replace the boiler, or if they're building a new building and putting in a boiler system, instead of that being a hard sell to get people to spend more money on the condensing boiler. It seems to be just kind of what's happening in the majority of cases, and I think that's partly been due to the utility programs that have been in place for a long time and have had great success, but it seems like it's reached a point where that's just what people are doing, and that's great in terms of the efficiency impacts. and that we're seeing that they're used in a wide variety of building types that have space heating boilers. It's not just concentrated in one type. And the efficiency concerns that were noted kind of verified what we had expected going into this project based on our anecdotal experiences with running across boiler systems and the other work that we've done and seeing what their operating conditions are. We had manufacturers representatives acknowledging that they believe that there's often very suboptimal conditions that the condensing boilers are put into, so that they didn't expect that they're achieving their rated efficiency. And also, it appeared that some of the part load efficiency improvements, there were some suggestions from some of the information that the part load efficiency improvements that are shown on some of the rating charts that show, if you operate at low part load, that you have higher efficiency, that might be overstated in some cases based on what happens with the burner tuning, because at the lower part loads, oftentimes the burner might not operate quite as well as it does might not be tuned quite as tightly as at the full load condition. Now I'm going to talk a little bit more about our monitoring and analysis and the findings that we had from that. Here's kind of showing what we a summary of kind of what we found looking at the boilers. And we'll start out by talking about what a hybrid system is, and that the hybrid system is one that has a combination of conventional boilers that are not meant to condense and condensing boilers. And that's something you run across both in retrofit and sometimes in new construction situations as a way to save money. In a hybrid, for example, in an existing building, you need to replace one or two boilers and not every boiler that's in there. You might try to leave one in place and then try to do a, control those so that at you're getting the efficiency out of the condensing boiler in mild weather, but you're not buying such a big condensing boiler that it has to handle all of the load in winter weather. So then you still use a conventional boiler when the loads are higher in cold weather. And kind of what we saw, if you see the kind of tan colored bars at the top, is showing the operating efficiency of the hybrid system combined. The blue bars represent for each of the site the operating efficiency of the condensing boilers, and then the lighter colored bars that extend farther out to the right, those are the rated efficiencies of the condensing boilers. So if we start by focusing on the lighter bars at the bottom compared to the dark blue bars, those are where it's just condensing boilers, and you're comparing what the rated efficiency is to what it's actually operating at based on the operating conditions that we observed, and you can see that there's a pretty significant difference there. And then if you add in as well the reduction in efficiency from taking into account the hybrid boiler as part of those systems, that can bring it down even substantially further in some cases, or in other cases maybe only a couple percentage points. And then this next slide shows a summary of when we looked at what the actual operating conditions were and looked at the systems. We found that there was often opportunities to improve the operating conditions within those existing buildings. And existing buildings and kind of what equipment is in place in buildings can provide a limit on what you can achieve with the condensing boiler efficiency, especially if you have radiators or air handler or heat exchangers that are designed for the higher temperatures of a conventional boiler system, and then you put in a condensing boiler into that building. You're not going to be able to bring the temperatures down as much as you might ideally want to for a condensing boiler system. So that's always going to have a limit on it. But even given limits of that and other situations, we saw that there was a number of opportunities to cost effectively improve the operating efficiency of those boilers with relative relatively low cost measures in most cases. I'll get into kind of how this breaks down in some of the slides further down, but by looking at a combination of smaller measures in most cases, this is showing, again, we have the lighter colored bars on the bottom are the rated efficiency of the boilers. The red was the combined plant operating efficiency as we found it, and then the green is showing what efficiency could be achieved by doing improvements to those boiler systems. And these are the kinds of things that either, given after a boiler has been installed, this could be done, or ideally at the time that a condensing boiler is being installed, that some of these things could be done, and some of them are cost prohibitive in the case of a system that's already in, but in other cases, some of those same things, if you do it at the time of the installation, especially piping type of changes, that it could be a lot more cost effective to do it at that time. And this is kind of showing the breakdown of the potential savings for different types of improvements that could be made to these, and how often these were found to be applicable. And in just about every case, we saw potential to be a little bit more aggressive in terms of the outdoor reset control, and that's reducing the boiler water temperature in milder outdoor weather. And we saw an average of about 1.5% savings related to that, and that applied, like I said, to almost every building. Similarly, boiler tune-up improvements, there is potential for that within every building. And for this, looking at boiler tune-ups, we found that even for boilers that are, even if they're operating within the manufacturer's recommended range of operation, there can be big efficiency differences within that operation. So if it gets tuned more finely to the lower excess air end of the range of recommended operation, that there's significant efficiency improvements that can be made by doing that. And that it varies from manufacturer to manufacturer in terms of how wide that range is and what the potential is. But a lot of these boilers where we were recommending tune-ups, they were already within the operating range, although there certainly were a few that were outside of the recommended range as well. And then the next improvement that we saw that was very common was staging control improvements, and this could include, even for an individual boiler, how well that was controlled in terms of it turning on and off. And we saw a lot of short cycling issues with boilers, even in situations of multiple boilers. You might have, in one case, there's 3 smaller boilers, and they would come on within a minute and a half of each other. They would ramp up, and one would come on. A short time later, the second one would come on, then the third one would come on, and then they would all cycle back off again within a very short period of time. It would repeatedly do that. So, and that's kind of an example of the different things that we saw in terms of staging controls. And again, it's a combination of building automation systems not being integrated well with the boiler controls themselves, and also in some cases even the manufacturer's built-in controls not always being set up and programmed as well as they should be. And next item that tended to not have as great a savings is the variable speed pumping, and that's what I outlined in this slide earlier in terms of how by reducing the flow rate you can improve the boiler efficiency somewhat based on our assumptions of what we thought could realistically be achieved, and we didn't see a lot of potential savings from that as much as we might have, as we had expected coming in. And I guess one thing I didn't point out is that these are not measured savings. These are engineering calculations of savings based on what we thought would be achievable with these buildings, and what that would change in terms of the operating conditions of the boilers, using the manufacturer's ratings of how the efficiency changes with temperature, how it changes with part load, firing rate, and we looked at how multiple boilers would be combined together and how they'd operate together within each system. And there was also 5 of the buildings where we found significant opportunities for piping changes that would increase the operating efficiency of the boiler. Although this only happened in a little under half of the buildings where these did occur, there was more savings than for any of the other measures. So in the buildings where it was applicable, we estimated 2% savings, and if you average that across all the sites, it's about 1% savings. But these also tended to be more expensive fixes. It would be things like the piping header on the boilers would be such that when one boiler fired, it would make the return water temperature of the second boiler go up significantly. So then that second boiler would be running at a lower efficiency. That's a fairly expensive fix to change that. In other situations where there was might already be a variable speed pump in place, there were three-way valves on the air handling equipment, and replacing those with two-way valves would help reduce the flow, whereas with three-way valves you end up having constant flow through the main building loop, so you don't get the same benefits that way. And this breaks it down into a little bit more detail, kind of showing in the axis is showing across the different sites. The green axis show which items were applicable to each site, and the red O's are showing which ones were excluded from this analysis, because even though there was an opportunity to do something at that site, it was not cost effective to do that. So this is showing that if you look at, okay, what's cost effective across these buildings, even after the fact, after the boiler system has been installed, if you go through and look at what could be done to make these operate more efficiently, we found an average payback of about 2.6 years in looking at those opportunities. And now I'll move on to talking about the results of our industry survey, in which we sent on an online survey to a large number of local boiler industry contacts across a range of people that played a range of different roles in the local commercial boiler industry. And I'll highlight some of our savings. In going into this, we were very interested in what because controls were a big part of what we knew was going to be a problem, and then also what we found where there's opportunities. We're very interested in how are these boilers being controlled, and what we found is that there's a range in terms of what's reported by people in the industry about, and the green bars in back are kind of showing, well, is it focused on the blue in front, we're showing onboard controls where it's part of a package that's supplied by the manufacturer, that's really the most common thing, and that those were in almost always or often. So those bars are showing that happened a lot more. There was also a significant number of cases where there was a building automation tie-in directly with boiler manufacturers' onboard controls. And then there's also, in some cases, some separate dedicated controls that are meant to control multiple boilers, but it's not provided by the manufacturer itself. And that's something that used to be more common with the non-condensing boilers, but it seems like the trend has been towards boilers having more control capabilities built in themselves, so that in large cases that separate control is bypassed. And we found issues when we had sites with any of these, in terms of even if it's onboard controls, if settings are left at defaults in some cases, that ended up not getting a good result. And with the building automation system tie-in, there was numerous problems across different sites in terms of not having good communication between the building automation system and the boiler control itself, and how those were coordinated, just causing short cycling in some cases. I think we're kind of fighting each other in terms of what they're trying to accomplish. And now talking about what the industry professionals saw in terms of witnessed efficiency impacts of what are the problems that they were seeing, and they saw 2/3 reported knowing that there's issues of boiler short cycling or turning it on and off too frequently. And nearly 2/3 of the 61% talked about difficulty coordinating control between the building automation system and the boiler itself. And then just under half reported problems with piping arrangements that would circulate water through a boiler that's not running, which is going to cause additional heat loss. Also, a number of people recognize that the boiler return water temperatures are often higher than they need to be, and kind of both of those last two both kind of address that. And in some of those cases, nearly half the buildings, people talk about 44% of the respondents talked about being aware of systems where the space heating boiler system is tied in with the domestic water heating system or service hot water heating system, and those have different temperature needs. So even in mild weather, when you don't need high temperatures for space heating, you might need high temperatures for adequately heating service hot water. So those can kind of not always be the greatest combination in terms of efficiency benefits. And now I'm going to briefly step through some of our findings in terms of what the what was considered most valuable in terms of different program features that could be added, and what would be considered valuable to people in the industry if this service was added to a SIP program in terms of a service offering. And even though all these different items here were ranked high, if individually, or almost all of them were ranked pretty high if they were individually asked those questions, this is where we really seem to see the big difference between the items. If we said, okay, out of all these ones, which is most valuable? That's where we really saw a breakout of there seeming to be a standout of being commissioning of installation and controls, and this is for what you might do as a condensing boiler is going to be put in for a new installation, whether it's a retrofit or a design of a whole new building going in. This is what was considered to be valuable. Or most valuable, even though each of those individual items most of those were ranked pretty highly. And then similarly, this is an owner of a building that already has a condensing boiler in place. What might be a valuable feature of a conservation program that would be helpful to them? And the standout there was new training options for the building operators in terms of different things that could be done. And then Dissemination, they have given multiple presentations at local industry events. We also have a final report that has been recently made available that has much greater detail than what we have in the presentation today. And the webinar today is our last thing planned that we have on that. And now I wanted to focus on the SIP program potential and the relevance of kind of what the findings mean in terms of a SIP program. And the first slide of two really focuses on how SIP programs could go farther in terms of getting energy savings. And on the positive side, we see there's definitely additional savings potential that's possible through a combination of control, piping, pumping, and burner tuning optimization. And I think this is and I think this is exciting in terms of that there's the opportunity to add new program features to achieve more savings either at the time of installation or coming back into a building that already has a condensing boiler in place. And we found that the hybrid systems that had had a combination of conventional and condensing boilers, those individual sites tended to have the most potential for savings. So focusing on those could really be a good benefit. And we found that of all the savings potential for the different measures, although not all of them were cost effective, we found that about 3/4 of the savings could be achieved with less than a 5-year payback. So that most of the potential that we had showed on the chart earlier could be achieved fairly cost effectively with a combination of that cost is split between a conservation program and the building owner. And we found controls adjustments and boiler and burner tuning were the most common and cost-effective of those items. I'm not going to read through completely this list here, but that's kind of the key finding there. And then also in terms of perceived value of possible SIP program features, I know ideally for ease of use of the program, it's nice to keep it simple, but what we found is that local contacts seem to have positive response in terms of the potential value of a wide variety of things that might help achieve a better result in terms of the condensing boiler operating efficiency. But the commissioning and training and support for changing of control settings are ended up kind of on the top of that list of what seemed to be a potential benefit of additional features that could be added. Now this next slide is going to talk about impacts on current SIP programs and kind of how they're being operated and findings that we found. First of all, the market penetration of condensing boilers has now reached a point where they've become the default, and that they're widely available, and they're just recognized by building owners as a cost-effective way to go. And the SIP program implications is that it's harder to say that that every boiler that's getting rebated is necessarily because of the rebates, even though I think that's a factor in terms of how the SIP programs are evaluated that might need to be taken into consideration. And also in terms of the in-field efficiency, we're definitely seeing that the condensing boilers are performing below their rated performance level, and far below that, and that's something that needs to be taken into consideration when you're looking at the SIP program impact of individual boiler installations. And I know that's something that's already addressed to some degree by some of the gas utilities in our area. And then also tune-up savings magnitude. I had talked before about how the condensing boilers are expected to be more sensitive to not having their ideal tune-up than conventional boilers, and that you can typically get more efficiency benefit by making tuning changes to the burner itself. And what we found even though we saw savings on the order of 0.8 of a percentage point, that seems to be below what's being assumed in tune-up programs now for non-condensing boilers. I think between that finding in terms of exactly what the reason for those differences are, it's hard to say if how maybe the condensing boilers are tuned better or not. It's hard to say, and kind of I think there's been enough condensing boilers going in that there's also at this point some impact on the mix of what boilers are out there in buildings, so that as a tune-up program should take that into account. And I think it may be time to kind of take a fresh look at boiler tune-up programs impacts and the design of boiler tune-up programs, and see if there's potential to make those better. That wraps up all the prepared comments I had. Welcome questions at this time.
Wonderful. Thank you so much, Russ. And I didn't prompt all of you listening intently on the other end when we got started, but we have a few questions that have come in, but if you do have any questions, we welcome those right now. We're going to take some time to answer any questions that you guys have. If for some reason we don't get through them today, we will respond to them and then post them on our website after the fact. Just for your reference, here's one resource at the top for where you could find the actual boiler project page and information about the project. And we'll show you later, but we are recording this webinar, and we'll be posting that on our website in the next few business days, as well as these slides for your reference. So we definitely have some questions coming in, which is wonderful. I think to kick us off, we do have a question about cost. And Russ, and this is maybe you might have to ad-lib this a little bit, but do you have any, can you give us just a little bit of a comparison of cost for a condensing boiler versus a conventional boiler so that people can, they're kind of asking about that and keep that in the back of their minds?
That's not something we looked at in detail in the study because we were kind of given that people are already doing condensing boilers, and it's something that varies by manufacturers. In general, I'd say the cost premium has gone down, and there's so much more competition, and it's something that's kind of changing. So I wouldn't want to give a good solid number on that one.
Okay. Not a problem. So another question is, how do you feel commissioning can best be accomplished through the SIP program, through program personnel or through a trade ally? Do you have other thoughts or recommendations on that?
Well, in general, what we found is that the level of detail of looking at the boiler controls is not something that in what we had to do to find these issues is not something that is addressed really well by a traditional commissioning of a building and a system, and that it's really a little bit more specialized look at it that we had to take in more detail at the boilers, and you have to dig down to the level of it's pretty manufacturer specific and control specific in terms of how they're what their control settings should be, what the ideal situation is. So I think it's a combination that I think we need to work through trade allies and make sure that they really understand these things well. So I think ideally you need to work hand in hand with the trade ally and get them to really be paying attention to this better. In the long run, that's definitely going to be the best approach to take, because if it's something that's just done by someone that comes through the building one time, there's going to be a trade ally or someone's going to be back through that system pretty regularly. There's at least they'll do an annual startup of the boilers typically, and if there's something that utility program does that the regular contractor disagrees with, depending on what that is, if that gets noticed, that might be overridden and set right back to where it was if there's not good education of the trade allies.
Thank you. I think that's a very interesting question and something for us to consider more deeply. So another question is, what is an example of boiler piping problems? Could you maybe expand on that, Russ?
Well, I talked earlier about kind of the piping arrangements that aren't ideal for condensing boilers, where the operation of one would impact the temperature on another one. So ideally, each condensing boiler would have the water coming back to it be coming right from the system and not being mixed with any water that's been heated by another boiler. Some of the other issues we've seen are if you, especially in some of these hybrid systems, that sometimes the old existing boiler would have water flowing through it all of the time. So it'd kind of be acting and just heating up air that's going to be going right up the chimney all of the time. That's another, I guess, a couple of the examples of the things we've seen.
We have a few other questions. One is, did the study assess the frequency of tune-ups for a conventional boiler versus a condensing boiler? Is the frequency or the recommended frequency of the tune-up different? And the duration of the tune-up, how might the life of that tune-up last?
That's not something we did a detailed comparison on. We kind of looked at just what the outcome is from the manufacturers in terms of what you would expect, what the manufacturer's ranges of what they want to see, and then what the impact would be of the efficiency changes within that.
Yeah, another question is, what is the range of the rated boiler output in the study with 11 to 12 sites?
I couldn't say exactly. On the low end, I want to say it's probably in the range of 500,000 BTU per hour or a little bit less, and that's a combination of 3 smaller boilers together. But we made a conscious effort to make sure that we included roughly half of the buildings being under 1 million BTU per hour and another half being larger than that. So we got a mix of what you might consider kind of small commercial systems and then larger systems. And we can put together more details on that. And I believe that's probably details on that are in the final report.
Great, and that'll be available.
It's available
already,
right
actually.
now
Yeah, on the website.
Yep.
So on that page that we shared earlier, and you can reference when we put the slides online. Another question is that we've seen that there are a lot of technicians out there that might not be qualified in performing boiler tune-ups. Do you have thoughts on this as a problem that needs to be addressed, or do you agree that that might be a problem in the industry in your experience?
Yes, I definitely would say that is a concern, and that that we've seen the contractors installing these and working with these, in some cases just leaving all these settings at factory defaults and not setting that up specifically for the system. And I know many years ago when CE was involved in designing and deploying a boiler tune-up program at that time it was more customized focus on a lot of buildings that originally had coal boilers that were converted, that there was definitely a high level of specialized training and selection of contractors that we used to make sure that we had got the results that we wanted out of that program.
Great. I think we just have 1 or 2 more questions here, but this might be asking you to stretch your knowledge a little bit as well, but do you know of any quality assurance programs that exist with contractors right now that are doing the boiler tune-ups?
Not offhand. I know that the other CE, or it's the Consortium for Energy Efficiency, that they've had taken some leadership on kind of setting some standards for condensing boiler programs and how to make sure you get efficiency out of those. And that's something that I guess you'd point to, and they're a resource for multiple utilities. So that might be a place to look for more information.
Great. I think that we've gotten through all of the questions as of now, but if you have other questions, please feel free to continue to enter them in the next 5 minutes, as we will take those and answer those and post those answers on the website. Or you can always contact Russ directly. But before we kind of talk about where you can find the recording of the webinar, we're going to hear a little bit about upcoming other conservation applied research and development webinar learning opportunities.
Thanks, Russ, for that great presentation, and thanks for attending this CARD webinar. Before we leave, I wanted to take the opportunity to mention a few upcoming CARD webinars that also might interest you. On May 18th, CE will be conducting another webinar on duct leakage in large commercial and institutional buildings. On May 24th, Franklin Energy will be conducting a webinar on the T12 lighting saturation study in Minnesota. On June 14th, CE will be conducting a webinar on reducing envelope leakage in multifamily buildings using aerosol sealant. Got some very interesting results. And then on June 22nd, CE will be conducting another webinar on improving the effectiveness of commercial energy recovery ventilation systems. So we've got a number of webinars coming up that I think would be of interest, and If you have questions or feedback on the CARD program, please give me a call or send me an email, or if you want more information on how to sign up for any of these webinars. And in addition to CE's website, the final report for this project and all projects are also available on our webinar as our webinar links for recorded webinars. Thanks, Megan.
Absolutely, and thank you, Mary Sue, for providing a broader look at other upcoming CARD learning opportunities. It's quite the season for them, I must say myself. And just to orient you to where you might be able to find, or where you can find, we'll be able to find the recording of this webinar and the slides. On our homepage, you can go to resources, and the drop-down menu, look at events and webinars is where you could find future webinar opportunities and where to register. But under reports and materials, you would select that and go into our webinar archive and be able to find any materials that we shared during this webinar, as well as the recording. And lastly, I just wanted to point out that if you are interested to be informed about other upcoming events, webinars, blogs, particularly related to research, you can sign up specifically for our quarterly newsletter on research or other newsletters that we do disseminate, and you can do that at the bottom of any one of our web pages. So without further ado, thank you so much for coming, and we hope you found this informative. And here are the contact information again for Mary Sue and Russ if you have follow-up needs. Have a great day.